We are Team 2, made up of Noah Luthi, Mohsin Ahmed, and Mohammed Abdullah. Our project title is Medical Data Aggregator, and we are working with Alan Fish from Code for Health. Code for Health is an initiative supported by NHS England and NHS Digital with the aim of using digital tools and technologies to improve patient care. The problem we currently have is that medical specialists are spending too much time on auxiliary tasks instead of with their patients. Due to the intensive study required in becoming a medical professional, their time is incredibly valuable and should be utilized effectively. By making use of digital tools and technologies, we can automate or improve the completion of secondary tasks and maximize the time that patients spend with the doctor. The task that our client has identified for automation or improvement is the searching of medical resources online. Currently, this process is very inefficient and time consuming, and so we'll be looking at making a solution for this. To solve this problem, we will be designing a website specialized for the searching of medical resources. The benefit provided by our website over general search engines is that the medical resources will be tagged beforehand using appropriate medical terminology. This tagging will be done using natural language processing and machine learning techniques and will be used to refine the searches made. The website will also allow the doctor to easily share these resources with their patients. Here is the table detailing the full list of requirements for our website. The main requirements are that there is a focus on search and that the user has the ability to mix free text with tags in their search. Additionally, there are requirements of sending resources to the patient and viewing the history of the shared resources with the patients. The overarching system architecture consists of 4 layers: the presentation layer, web services layer, data access layer, and logic layer. Within the presentation layer, the main technology used was the React JavaScript library. This was used in conjunction with HTML and CSS to create the user interface functionality. This was also where the details for the design and layout were realized and implemented. For the web services layer, we used the Flask micro framework to implement a RESTful API to enable communication between the presentation layer and the backend. As part of the data access layer, MongoDB was our choice for data storage. There was mainly 2 different types of data that we needed to store. First being the medical resource data that has been scraped and tagged by the logic layer, and second is the user profile data that will be created by the front end. The logic layer comprises of multiple different tasks that need to be carried out. Firstly, the Scrapy framework was used together with Beautiful Soup library to extract medical resource data from multiple different websites. Next, in the logic layer, the scikit-learn and gensim libraries were used for topic modeling. The medical resources would then be appropriately tagged based on the medical topic that they relate to. Upon first opening the website, the user is met with this screen. From here, they can click the search button and input their search query. They will then receive a list of all related resources and can access them by clicking on their URL. They can then select any resource and input the email addresses of the patients that they intend to send them to. This will open up an email client with the resources already added and the recipient specified. The key achievements of our project are that doctors can input text and select tags to be included in their search for medical resources. Medical resource information is gathered from multiple different websites to be searched. Appropriate tags are applied for each medical resource. This has been the Team 2 Medical Data Aggregator project video. Thank you for watching.